Hello, I'm going to explain some basic trigonometry. So let's start with an equilateral triangle. Each corner is going to have 60 degrees. I'm going to explain where we get the 30, 60, 90 triangle, the 45, 45, 90 triangle. That will lead into concepts of sine, cosine, and tangent, and then I'm going to talk about the unit circle. So we have this equilateral triangle, and I'm going to draw a line right down the middle of the triangle. So now we created a triangle. We created a right triangle. So the side length is x. So that would mean that this line is the bisector of this side. So if each side length is x, then this length right here would be 1/2 x. And then in order to find this side length, we need to use the Pythagorean theorem. So by using the Pythagorean theorem, we can see that x squared will equal 1/2 x squared plus whatever this is, and we'll just call it h for now, plus h squared. So then when we solve for h, let's move all the x's to one side. So we have and then this becomes 3/4 x squared equals h squared. Now we are going to solve for h, and we have the square root of all of this equals h, and the square roots of this is equal to this. So this is where we get the concept of the 30, 60, 90 triangle. So I'm going to draw this bigger. Where this is x, this is 1/2 x, and this is h, which we know has the value of √3 over 2x. So we have this is 60 degrees, this is 90 degrees because it's a right triangle, and since we have the bisector here, we know that this little portion is going to be 30 degrees. So this is our 30, 60, 90 triangle. Why is this important? Because it introduces us to sine and cosine of 30 degrees and 60 degrees. So sine is opposite over adjacent, or opposite over the hypotenuse. So we first have to pick an angle. So let's pick 60 degrees. We are going to find sine of 60 degrees, and we are going to find cosine of 60 degrees. So let's start with sine. Sine of 60 degrees is equal to the opposite over the hypotenuse. So we are going to have that sine is equal to root 3 over 2. Sine of 60 degrees is equal to root 3 over 2. Because when we take opposite and we divide by the hypotenuse, the x's cancel. And I'm just going to make a note here that root 3 over 2 divided by x because the x's cancel. So we have sine of 60 degrees equals root 3 over 2. Now cosine of 60 degrees is going to be equal to 1/2. How did I get this? I got this because I took the adjacent and I divided by the hypotenuse. So we have the adjacent, which has a length of x over 2, and divided by the hypotenuse, we just have 1/2 because the x's cancel. So to make this more formal, sine of any angle that we are going to call theta is equal to the opposite over the hypotenuse. So the opposite side length of our 30, 60, 90 triangle happens to be this, and the hypotenuse happens to be this. Now we have the cosine of theta is equal to adjacent over hypotenuse. We have our adjacent side length, which is x over 2, and our hypotenuse, which is x. Tan theta is equal to opposite over adjacent. So we have opposite, the opposite side length, and we have the adjacent side length. So those are the three basic ones. So an easier way to look at this now is if we turn to the unit circle. So by turning to the unit circle, we are going to have x equal to 1. So I'm going to create the same triangle and just have x equal to 1. And I will go into the unit circle later, but I will just have x equal to 1. So it's easier to see how sine of 60 degrees is this and cosine of 60 degrees is this. So I'm going to redraw that triangle. And we're just going to make x1. So you can see more clearly that this, if this is a side length of 1, then this will have a side length of 1/2. And this, which was formerly our height, will have a side length, will have a length of root 3 over 2 in our 30, 60, 90 triangle. And now I'm going to go to the 45, 45, 90 triangle. And I'm just going to make the point that tan theta is equal to sine theta over cosine theta, which you can see right here in this case, tan theta would be root 3, because root 3 over 2 divided by 1/2 is root 3. So yeah, these are pretty much the same thing when you think about it.